Okay, so now let me introduce our element one. Here, the situation is that we need to use the Q and the Q to solve a problem. The situation is that we assume that we have a lot of users and they need to and they may report the problems when they buy the ticket. Now let's see the data I prepared. Here it's like uh, this is the ID and the username, the reason, but that's not important. The most important thing is here, normal and this urgent. It means that if this is urgent, we need to handle it firstly, and if it is normal, we need to handle it um, with the rule of first in, first out. And then let's just run this. Okay, so now we can see that when we processing using Q, we need a lot of time, and when we using the Q, it need less time. So let's see why is it. Uh, the Q I used two Qs. One is urgent Q, and the other is normal Q. If the problem is urgent, it will enter the urgent Q to the tail of it, uh, and if it is the normal queue, it will enter the normal. If the problem is normal, it will enter the normal queue. It will enter the tail of the normal queue. So then we will handle the urgent queue firstly and normal queue secondly. Now when we use the queue, uh, and if the problem is urgent, we can just add first. That means we will add it to the head of the queue, and if it is a normal problem, just add it to the last. So then let's see the stack. This is how I implemented the stack. I used the node. It's just like the linked list, and I have implemented the methods that would appear in the official stack. So just to test this, I plan to do the push and pop operation for 1 million times. So let's see how much time it needs. Okay, it seems that our stack is even better than the Java official stack when we pop and when we push and pop for 1 million times. Then it is a queue. This is similar to the stack. I also used the node, the front and the rear, and I have implemented the method such as enqueue and dequeue. In queue, it's just we add it to the end of the queue, and when dequeue, we just get a node from the head of the queue. So let's test its efficiency. It's just the same as the stack. I have tested the enqueue and dequeue for 1 million times. Let's see the efficiency. So it is very interesting that our queue uh, is much more is much faster than the official Java queue. So it means that the queue we implemented is to some degree very good. And then this is my queue. It is also it is also used the node, just the head and the tail. So add first, add it to the first, and add last, pull first, pull last, a lot of methods, and then let's test its efficiency. Okay. So here my DQ is a bit slower than the official array DQ, but I think the difference is small, so it is to some degree a good enough data structure. Okay, so this is all. Thank you.